Hello, everybody. Very nice to meet here with you today. My name is Telemaco Melia. I'm General Manager for EchoStar Mobile. EchoStar Mobile is a satellite company providing mobile satellite services across Europe. And the goal today is to explain you what the team has been doing for the past 18 months to build from scratch a satellite extension to a system, LoRaWAN, that is traditionally conceived for terrestrial operations. So what I'm going to use is a few use cases that we've been encountering quite often talking to customers lately. And walk through use cases out to explain some of the challenges that we've been encountering, how we overcome them. Traditionally, what the LoRaWAN ecosystem has been doing has been showing great achievements. We know, that today has a global presence, 170 plus networks, public and private deployments, thanks to a very flexible standard, which is giving you the possibility of doing different deployments, something that, for instance, cellular people just achieved in the recent years. However, when you do that and you look at how we can increase coverage, that's clearly not enough. Long range is not enough. 90% of the ground is not covered by coverage. When you want to extend coverage, you encounter issues if you want to move between different geographies. It's difficult to deploy this type of technology in places where you have low density, for instance, and then it becomes, from a commercial standpoint, not viable. And this is the industry giving us feedback, it's difficult to set up roaming agreements. It can be, not technically, but commercially it becomes a headache. So the question is how you really can achieve 100% coverage. The obvious answer to us is satellite. And let me explain you what we did and what are some of the key characteristics that I believe are really relevant for this market. So to date, EchoStar Mobile is the only and single and largest LoRaWAN network across Europe. We provide pan-European coverage. And it's really a matter of giving you coverage if you move from point A to point B, west-south, across the 27 member states. Some key characteristics of the work that we have been pushing forward. First of all is real time. It means that you don't need to wait to send or receive a message. The geostationary asset is providing you connectivity, and you can send uplink and downlink messages almost in real time, as you would do with a terrestrial network. Second is bidirectional. It means that you have the possibility to send uplink packets, so from the field to your cloud service, for instance. At the same time, then you can receive answers from the cloud service because you may want to take actions in the field, which is a key characteristics of our solution. We use licensed spectrum. LoRaWAN today is traditionally working non-licensed spectrum. One of the key characteristics of the solution we propose is working the S-band, which is 2.1 gigahertz, and provides quality of service which is unprecedented in the LoRaWAN ecosystem. And if we know that this is not part of the standard. We are talking to the LoRa Alliance Technical Committee on Friday, so we really encourage you to join the session on Friday, and we will be walking through some of the key challenges that we've been encountering while working on LoRaWAN. And then the next step for us was really, we want to be compatible with the existing ecosystem. We didn't want to create a silos. We didn't want to create a proprietary technology. We wanted to work with something that was already well established and well adopted by people. We didn't want to explain yet another standard. We wanted rather to say, hey, here we are. We can work with you. We can complement existing coverage with something which is going beyond your current capabilities. And really, the goal was to provide feedback to customers where they were asking us, the problem is coverage. So the network is really, animation is not starting, is really providing continuous coverage, and the goal was really to let people move freely across boundaries, not only in regions where there is no network, but also in regions where there is no coverage because there is poor connectivity. Typically, places where IoT plays a key role. So let me now walk through some of the use cases that we have been looking at. It's not an exhaustive list. It's something that we think is representative, but obviously feel free to come to us and we'll discuss more offline. So one of the first challenges that we have been confronted with was, okay, what about if I have mobile assets that move between different geographies and I want to track them? So clearly mobile assets can be geolocation, it can be cold chain, it can be logistic, transportation, anything that will require to be tracked. And it doesn't mean to be tracked on a minute, it can be every hour, but still, today, that use case is not possible. So the goal for us was really how we can enable this use case, bringing together a solution that can give you the chance to track your asset across different geographies. One other use case that was really interesting to us and that uses the capability of having uplink and downlink is what we call the advantage of using both directions, the bidirectional advantage. So imagine today, you can collect data from the field, but often the data lands in the cloud, you analyze it, but it's not actionable. So the goal for us was really how we can enable use cases to receive the data and then take actions and transfer these actions back in the network. Pipeline is a good example. Valves that are in the field detecting leakage, for instance. Leaving them open is creating you an operational loss. So having the option of closing down is clearly something that was valuable to people. Considering also that you can send acknowledgements. So it's not only a matter of sending packets up and down, it's also a matter of, do I acknowledge the fact that the valve has been closed and that finally, I can send back the message to the intelligence center. So really giving you the option of the bidirectional effect. We understand that this is some use cases will not require, some IoT objects will live fine, just sending uplink packets. But for the type of services we are looking at and the type of customers we are targeting, we believe that this is one of the key features that we want to be, part of the product. One other aspect is really how we can collaborate with existing ecosystems. And one good example is warehouse and industrial type of deployments. We said before, LoRa is a great standard. It gives you the option to deploy public and private networks. But if warehouse A and B are transferring assets, often in transit, they don't know where the asset is. Maybe lost, maybe not. So one of the options is really giving the opportunity to people to track between warehouse A and warehouse B. And while objects are in transit, they will connect to satellite. And if you get to the warehouse, then they can use the existing network. How we did it? We developed a modem, and you'll see a slide later on giving you the option of using both ISM bands, so unlicensed, and satellite. So it's really up to the application developer to define how to use the best network at a given point in time, and the option of moving on and off of the satellite network depending on what the application is demanding. This is something that today is not available in the market, and we saw a clear need for this type of deployments. And again, in the interest of augmenting current networks, not replacing satellite as an advantage in some situation, like outdoor, clearly is not an indoor technology. So leveraging existing ecosystem obviously was the most sustainable solution for us. So conscious of time, and 15 minutes go fast, if today you leave this room and you need to keep in mind 3 key messages, we are a network operator, so you should see EchoStar Mobile as a pan-European network operator. We have been the first to deploy the largest LoRa network in Europe, so it's a single network, and is LoRaWAN compatible. So we cannot say and claim we are LoRaWAN compliant, because we had to take the standard and change it to be working on satellite. But we are conscious that the changes we did are minimal and were necessary to get it running in our environment. Again, we'll be talking to the LoRa Alliance Technical Committee on Friday. We will be exposing how the problem was addressed. We'll not say how we solve it. This is not yet the time, but really happy to meet you there and discuss further the topic. So, in a nutshell, today we exist, we are live, we have a pan-European coverage that is available for people. We have modems, as you can see in the picture there. We really took great care of building on, putting on the market something which is, responding to customer needs. It's a dual mode module. It provides both satellite and terrestrial connectivity. And I think one of the key elements was to make sure the technology can really be, is user-friendly. People are used to in terrestrial deployments to some sizing and typing of footprint of devices, and we try to be as close as possible. I think one of the key aspects is the antenna. People that work in the satellite industry are used to large flat panel antennas. What you can see here in the bottom picture is a small, cheap antenna, which is also cheap in terms of pricing, but is really the footprint of the antenna is really small. So the goal is to give partners, integrators, and customers the option of using something which is small and viable from an integration standpoint. Allow me to conclude the talk with a call for action. We launched back in April what we call our LoRa testing program. It's a program for early adopter that really would like to get going with the testing of the network and integrating have an early integration of the solution in their products. Today we are talking to a variety of people that include different verticals, like railway, utilities, smart farming, smart agriculture, assets, managers, that really have the key issue is how do I get connectivity in places where there is no coverage for the variety of reasons I explained before. This program will be running until the end of the year. To date, we onboarded or are onboarding about 17 partners, and we really, encourage you to come to us and discuss how you can be part of that program. Commercial activities will begin towards the end of the year in Q4, and the time between now and then is really a matter of having free access to technology, being able to get access to our technology team and discuss how actually you can be onboarding and integrating efficiently this technology into your roadmap. We are available at booth 70. We can run demos. We have devices. All the team is there to meet you. It has been a great effort. We are now at the beginning of something new, different, which we hope the LoRaWAN community will greatly adopt. And I think I'm just on time.